Hello and welcome back for another VMK in the C++ series. In this VMK I'll be explaining how you can use threads within your C++ programs. Let's just jump right in. I'll create a new project by going to File, New, and then selecting Project. I'm going to select a Win32 project and I want to create a console application. I'm going to change the directory where I place this project. So under here I'm just typing in VMK project/C++, and the name for the project that I'll give is VMK 15 threads. I think that's the number we're on. Let's just quickly take a look. Yeah, 14 was templates, so 15 is threads. Okay, just hit OK. Then under the application settings, I want to select console application. I don't want to use precompiled headers, so uncheck that box and everything else is fine. So we can hit finish and then we have our general template here. Now I'll make some modifications here. Since we're not using precompiled headers, I'm going to copy over the important information out of the stdafx.h file, which is basically these two includes right here. I'll paste them right here. And then we can go ahead and delete all the files that it created by default, all the files that we're not going to need. We're not going to need this guy here, so I'll just go ahead and delete him. We won't need this guy, so we'll delete him. And we also won't need him. And finally, the README file we're not going to need as well. So we're just left with the VMK15 threads.cpp file. Okay, so what are threads? Threads are a way that you can make a computer perform two operations at a time or more. You're not restricted to just using two threads within an application. Things do get complicated when you introduce more than one thread. By default, when you create a program, you have your main function, which is your start of your thread or your process. And whatever you type in here, basically the execution starts from this line and goes forward. When you return out of the main function, you're basically exiting your main thread, and that's the end of the program. However, when you're implementing multiple threaded applications, you can spawn multiple threads or another, for instance, main function out of this one to create a second stream of logic. And you do this for many different reasons. The more common ones that come to mind are things like creating a process bar. So if, for instance, you were loading some data in the background, but you wanted at the same time to display to the user how much of that loading has been completed, so you have some sort of indicator like 10%, 20%, 30%, and so on. You want that indicator to update automatically while there's processing happening in the background. So there you would create a working thread. The working thread would perform all the work in the background, and then you'd have your display thread, which would be showing you specifically where the progress is inside of the working thread. Another example where you'd want to use threads is when you're processing music. Music you'll want to run in parallel to an existing program. So you might have some sort of visual effects showing up on the screen, but at the same time you may want to process some audio buffers, transfer some data from a file into memory, things like that, so that you have continuous audio streaming through the speakers. To do that, you could use multiple threads. You could have an audio thread that handles all the audio processing, and then you could have a graphics thread which would handle all the graphics. And by running those two threads in parallel, you can make it appear that both things are happening at the same time. So that's what threads are. Now let's take a look at how we can implement some threads here in C++. I'm using Visual Studio 2008. This code should be compatible with 2005 or other versions of compilers, but if you do have any problems or questions, feel free to post them inside of the forum section found here at www.maticknows.com. Located under the C++ VMK section, you'll find a posting here for VMK number 15. So if there's any questions specific to this VMK, feel free to post your questions there. I'm going to start off by creating a very simple for loop here, which is just going to iterate 10 times and display the number to the screen. If I go ahead and compile and build this program, you see that we get the numbers from 0 through to 9, and then the program is done, so it displays press any key to continue. Basically, the way that I did that is I just pressed Control F5 on the keyboard. It automatically built and ran my program, and it also leaves this window open so that you can see the press any key to continue. If you go ahead and select Start Debugging, you'll notice that the window opens briefly, and then once the program is done, it closes the window automatically. So the only way you'd be able to see the output is if you press in here, create a breakpoint, then you can start the debugger. You'll notice that the program stops execution here and it's waiting. While it's waiting, you can open up that window and take a look. But basically, to avoid having to do those extra steps, I'm just pressing Control F5 here to show the results to the screen. Okay, so we have a simple loop here that loops 10 times and displays the number. Now let's start a second thread, and while this guy is running, calculating these numbers and displaying them to the screen, I want the second thread to do the exact same thing. So here's the second main function that I wrote. The declaration is very specific so that your thread functions are always returning null, and the parameter that you pass in here is a void pointer, and I just called it here pparam. I'll talk about this parameter shortly, but for now let's just go with what we have. Inside here I have a for loop. Again, it's looping through from 0 to 10, and this time I'm printing thread number 2, and then it's going to show the number. Obviously, if I were just to call this function up here, then what happens is, oh, what do I have here? A typo. Oh, I forgot to pass in a parameter here. I'm just going to pass in null. If we're to do this, then you notice that our second thread, our main 2, runs through the for loop from 0 to 9. Once it exits, then we run through our main thread from 0 to 9. That's not the behavior that I want. And if I were to move this down below, then that also isn't the behavior that I want, because first we run through thread 1 and then we run through thread 2. But what we're trying to achieve is have both of these run in parallel so that we basically see that 0 shows up for thread 1 and then 0 shows up for thread 2. Then 1 for thread 1, 1 for thread 2, 2 for thread 1, 3 for thread 2, or 2 for thread 2, and so on. So we want to intermesh both of these function calls so that they're all happening at the same time. Now, they're not necessarily going to be happening at the exact same time, but it'll be perceived to happen at the same time when you use threads. So let's go ahead and remove this function call down below. One thing I did want to finish off with is how you handle threads if you're inside of a class. If you are creating a class that will be spawning a thread, then you need to declare your thread functions as being static. So let me just quickly write an example here of how you do that. I'm just going to create a very quick and dirty class here. Actually, what I'll do is go into here and just quickly add in a new item. We're going to be adding in some CPP, call it my class. And I'll also add in a header file. Then don't forget your standard if not defined. Then we're going to define it. I'll have a constructor, and then I'm declaring a static void function called thread, which has a void pointer as the parameter, and I also need a static member variable here, which is going to point to myself. So then inside of myClass.cpp, here's the constructor. I'm setting self to be equal to this. I'm going to start my second thread, which I'm passing in here as this guy here to be the thread start. And then I'm going to go into a for loop to iterate here 10 times and display those numbers to the screen. The second thread is going to basically do the same thing, but only 5 times, displaying thread 2 and then its own numbers. Don't forget to actually associate some memory with this guy. So at the very top here, just say this guy is equal to null. Let's go and compile him. And what do we have here? Oh, null is not defined because we're not including the Windows header. We can just set that equal to 0. And do the same thing here. Oh, begin thread is missing its own include. So we'll need, let's go into here, add in process.h. Are we using sleep in here? No. Okay. Printf, we are going to need some header files. Let's just copy all of these over. And down here, what do we have? Illegal escape. Oh, there's a typo. Okay, so that compiled fine. Now going back into here, let's take this out and include. And then down inside of our main, we'll just have my class M, and that's it. Everything else I've commented out. So now let's give this a try. So we can see here, we've gone in 0 to 10, 0 to 9 for the first thread, 0 to 4 for the second thread, and everything seems to be working fine. So again, if you have any questions, come down to the website and post your questions inside of the community forum. Now the way that we create a second thread from within a thread that's already running is we call this begin thread function call. The first parameter is the name of the function that you want to be the start of your second thread. So here I'm designating main2. And for this to work, you must be sure that your declaration here is void and you're passing in a void pointer as your parameter. The second value here I'm specifying 0, and the third one I'm specifying null. Now for your compiler to recognize this, you'll notice that if I try to compile this, I get an error message saying that begin thread is unidentified. So for your compiler to identify what this thing here is, we need to add an extra include, and that's stored in process.h. Again, you can find this information out if you just to double click on that, press F1, and this will open up MSDN, the documentation for inside MSDN, and it'll show you specifically what you need to include to use this specific function call. You notice here's some description on begin thread, describing you what all these different parameters are that you would be using, and then at the very bottom here it tells you to use process.h as the required header file. So now if we're to compile this, you notice that it succeeds. So pressing Ctrl F5, you notice now we've interweaved both of these calls. We have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on, all the way down to the bottom. The last one here is a little bit peculiar. You'll notice that thread number 2 ran twice and it displayed 9 2 times. But basically what we're doing here is we're not controlling what happens when one thread exits with respect to the other. So for instance, let's see what would happen if our first thread is running. It's only going to run 10 times, but we say that the second thread has to run 100 times. So let's see what would happen. Well, we see that thread 0 is at 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then after thread 1 finishes, thread 2 basically gets terminated, and we have this weird anomaly here where we're getting number 9 showing up twice. Well, let's see what happens if we go the other way. Thread 2 now will finish before thread 1 because thread 2 only has 5 items to display, whereas thread 1 has 10 items to display. If we compile and run this, then we see that the program does run properly, and we have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Then thread 2 is completed, and then we continue on with thread number 1 to its completion. So ideally, you don't want to be finishing your main thread from which you spawn other threads until all the spawn threads have completed as well. So you need to have some sort of handshaking between your main thread and the threads that spawn from it. And that's basically what we can use this extra parameter here for. We can pass in a value by changing this parameter here, and then whatever you pass into the last parameter is going to show up here inside of your second thread. At the top here, I'm going to create a structure, and this structure is going to be passed into the second thread from within the first thread. I'm going to call it my variables, and notice that it contains 2 items. There's a Boolean value which is called bdone, and an integer value which I just call iValue. Also notice that the structure is declared as being volatile. What this means is that either thread will have access to the data here, so I'm telling the compiler, please don't optimize this structure, because even though it may look like this variable is not changed within one thread, it may be changed within the second thread. So it's always best to declare variables that you use within multiple threads as being volatile. Alright, then inside of the main thread, I'm going to declare some variable that is using this structure. As shown here, I'm just declaring my variables, call it var. I'm going to set the done value to be false and the I value to be 10. Then, in the third parameter here, I'm going to see that it has to be a void pointer. So I'm going to take the address of my variable, that is this guy here, and pass it into my second thread. Inside of the second thread, this variable is coming out here, so what we need to do is first cast it over to be a myVariables object, which I can do like so. I know that p parameter is a void pointer, so I'm just going to cast that over to be a pointer to my variable object. I'm just saving that into pvar. Now inside of the for loop here, instead of using 5 here, I can say pvar and extract the I value. So here I'm specifying 10, which means I want this loop internally here to run 10 times. Then once this second thread is complete, in other words when this for loop is done, I'm going to take pvar and assign a value to be done to be equal to true. Then down below here, what I can say is, okay, I know that be done is false and is only going to go true whenever my second thread is done. So down here I can do a check to see if the second thread is done. And that's this code here. I take the be done variable, I check to see if it's true. If it's true, then this guy here is going to be false, so I don't print anything to the screen. And this guy here is going to be false, so I just return out. However, if this guy is false, the negation operation is going to make this if statement true, in which case I'll print to the screen thread 1 is done, waiting for thread 2. Then we'll go into this while loop, and we'll just continually loop through here, waiting for this variable to trip so that we can finish off thread number 1. Now if I were to compile this, I'm going to get an error message saying that it doesn't know what sleep is, so we need to go up to the very top here again, and this time we need to include windows.h. That's where sleep is defined. So now if I compile that, you notice that it succeeds. So let's give this a run, Control F5, and see now we have 0011 all the way through to the end. We have 99, and then thread 1 is done, so we're waiting for thread 2 to complete. When thread 2 is completed, then we actually exit the program. As a better demonstration, let's finish thread 2 early and see what happens. So I'm going to change that 10 value to a 5. So now we can see thread 2 finishes here, but thread 1 still has some more numbers to process. So it continues on and then it's done, then the program finishes. If I change this around the other way, so let's say I make this equal to 25 and run it through, we notice that the program starts off, interleaves everything up to 9, then thread 1 is done, but it's still waiting for thread 2 to complete, because thread 2 still has to process all the numbers down to 24, in which case, once thread 2 is done, it exits out, and then thread 1 can continue on past this while loop and finish itself. So this is a better way to handle the synchronization between one thread and another, because now we have an ability to monitor when thread 2 is completed all of its processing. Now, as another demonstration here of how the threads are working, let's put in a little bit of a sleep statement inside of the for loop so that we can delay the interaction between these two guys. Let's sleep this guy for half a second, and let's sleep this guy for, I don't know, let's say half a second as well. And I'll change this back down to 10. So now when I run this through, we can see each of these are being processed. But notice that sometimes, even though both threads have been told to run in synchronization, in other words, both have that 500 milliseconds, sometimes thread 2 ran twice. Because as I was saying earlier, you're not guaranteed to have both of these running in exactly the same time. The timing is going to be slightly off every now and again. So you have to realize that if you're transmitting data from thread 1 to thread 2, or the other way from thread 2 to thread 1, your data may become unsynchronized when things like this happen. So you can play around with these sleep values, like change one around, make it 300, make the other one 500, run it through and see basically how many times each one runs through inside of the for loop, just to get a feeling for what's going on. Now, the way that I've described communication here between one thread and another using this variable, this works, but it's not the best way to handle this kind of synchronization. There are special objects already developed for you that are recommended to be used whenever you're passing data from one thread to another. So a better way of creating this handshaking between the first thread and the second thread, instead of using this be done value, is to use a mutex. Mutexes can seem kind of scary, but they're really very simple. What I'm going to do is inside of this second thread, actually what I'll do is actually create a new thread. I'll call it main3. Also, it's going to have the same parameters. And at the very beginning, when I first enter into this thread, I'm going to create a mutex. And it's going to be a named mutex. So I'm passing in null, true, and then the name of the mutex that I want to use. This could be any string that you'd like. I'm just calling it thread2. He's going to return to us a handle to the mutex. At the very end of this function call, you release the memory that you create by calling create mutex. And you can do that by calling release mutex and passing in the handle. Now, inside of this function call, I'm going to do the exact same thing that I did before. Take all these guys, paste it into here. And so we're still taking that parameter. We're using it for figuring out how much time to spend inside of the loop. And then at the very end, we're just releasing the mutex. Now, down below here, instead of using main2, I'm going to use main3 this time for this demonstration. I'm going to crank this up to be 25. And down here, instead of checking to see if we're done, because we're no longer updating that variable, we need to create a better mechanism for handling this kind of check. So after thread 1 finishes, using this for loop here, I can do the following. So I'm going to print waiting for thread number 2, and then I'm going to open up the mutex that has already been created earlier because it was created when I began the thread. And I'm looking for that same thread that I named up here. I called it thread number 2. So here I'm saying, please look for thread number 2. The return value out of this function is going to come from calling wait for single object. I'm passing in the mutex that I'm interested in, and the second parameter defines how long do I want to wait for. So this, in essence, is that while loop that I had down below here. I'm specifying I want to wait indefinitely until my mutex is released or it's completed inside of the other thread. In which case, wait underscore object underscore 0 is going to be returned from this function call. So then I know that thread number 2 is finished. I'm just going to print here to the screen finished, and then we're going to close the handle for this open mutex here. If I have a value specified here other than an infinite, for instance, some large value like 10,000, that's going to represent 10 seconds, then I'll either get this value or I'll get a default value which will tell me that this function here has timed out and the mutex hasn't actually been released. So that's another way to handle your while loop. Let's give this a try. Oh, create mutex is trying to be called as a ANSI function call. I can just quickly go into my project settings here and specify here that my character set is not going to use Unicode. I'm going to use multibyte, hit apply, and then that should fix the problem. Okay, so let's give this a run. Notice that thread 0, 0, 1, 1, 2, 2, all the way through, and here I finished thread 1, and now I'm waiting for thread 2 to complete. So then we continue on through until thread 2 is complete, and then we exit out. So the behavior is exactly the same as what we had earlier. I can change these delays so that it's a little bit, oh, wrong one. I'll change this guy here to be 100 and this one down here to be 100 as well, so that we can more quickly see what's going on. Basically, thread 1 goes through from 0 to 10, or 0 to 9 more specifically. Then it's completed, so it's waiting for thread 2, and thread 2 continues on to number 25. When it's finished, then the program exits out. If I change this number to be 5, for instance, then we won't wait after thread number 1 is complete. We just automatically finish everything out. So mutexes are very handy for synchronizing between threads by using the name of the mutex that you're interested in looking at. while that mutex is active, whenever you create it, it becomes active, and then we can monitor its activity by calling wait for a single object. If you want to know more about mutexes, just go into the help files under create mutex, have a read through all the different parameters that you can pass in here, and there's also some relatively good examples of how you'd use these and what you would do with them. More importantly, though, take a look under the synchronization functions, because in here there's a whole bunch of stuff that is very helpful when you're dealing with multiple threads inside your application. If you want to do asynchronous function calls, if you want to do critical sections, I'll talk about those shortly in this VMK. If you have events that you're calling, if you have interlocking function calls to prevent things from overlapping on one another, you use these guys here. And then there's the mutexes that I just finished talking about here. And there's also semaphores, which are also handy. They're very similar to mutexes, but they have a slightly different purpose to them. And then there's also timing functions. And then down here, this is where that wait function is that I was just talking about. If we scroll down here, we have wait for single object. So in here, you can have a read through to see what's going on and what the return values can be for a specific synchronization object. All right, so going back into here, we now know how to communicate forwards and back. Oh, I didn't actually describe how to communicate back. Again, using your parameter, we have a variable here that we have access to from both threads. So what I can do is actually, for instance, say I create a floating point number, f value. Inside of the main thread, I'll give that guy some value. F value, say I'll make it equal to 0. Then once this guy completes, I'll display to the screen value is equal to var f value. And then once the second thread is complete, I'll also display the same parameter. Then once the second thread is done, or actually it could be anywhere, I'm going to define a new value for this guy. What was he called? pvar f value. Let's make him equal to some number, I don't know, 3.14. Let's give this a run. We see that thread 2 finishes early, so it obviously updates the value. Let's just update some formatting here. Put some carriage returns on the end, and instead of running it 5 times, I'll run it 12 times. So let's take a look at that value. We see that when thread 1 completes, the value is still equal to 0, but when thread 2 completes, it automatically updates the value inside of that structure, and you see that now it's equal to 3.14. So within our main thread, we don't actually set the value to 3.14. It happens in a separate thread right here, but we still have access to it within the main thread. So this is a way that you can pass data back and forth. You have to be very careful when you do this kind of work, though, because if you're writing a value to a parameter or a variable from within 2 threads, you could get problems. And the problems would be things like in thread 1 you overwrite it to a value, let's say 1, and then thread 2 overwrites it to a value 2, and you never really see it at the value 1. I'm going to show you a demonstration of this happening. Be aware that when you are using a variable that's being accessed by both threads, be very conscious on when each thread has access to that variable and whether it makes sense to have both writing to that variable at the same time. Most of the time you don't want to do this kind of work without having some sort of protection around your variables. Let's now take a look on where you can get into trouble if you don't protect your variables. I'm going to create another value here. Oh no, I'll use this guy here. I'll initially set it to 10. Then down over here, I'm going to create another new main function. I'm just creating duplicates here so that later on, if you guys have questions about a specific function, I'll have reference to look through, because I'll probably forget by the time these VMKs come out. Okay, we have this guy here inside of this for loop. I'll delete this guy here. We won't need that for this demo. Okay, inside of this for loop, I'm going to have the following. I'm going to take that variable, which I declared down here. I'm going to don't worry about this. I'm going to change this in a second. But basically, I'm using this structure's variable, I_value, and I'm setting it to some value. I'm here inside of this second thread, I'm setting it to be equal to 10. Then I'm going to introduce a small delay here to represent I'm performing some sort of calculation, whatever. And then I actually want to display the value to the screen. So I'm taking the value, passing it out, and then I also want to output here a string to represent whether this value is equal to 10 or not. If it is equal to 10, then I'm going to display good, meaning that the value hasn't changed between the time that I set it and the time that I print it. Otherwise, if this value has changed, then I'm going to display bad to show something bad happened because another thread interfered with this thread. Then I'm just have a carriage return, and I also wait another 0.1 seconds. Inside of the main loop, I'm going to do basically the exact same thing. I'll comment all of this out and replace it with the following code. Inside here, we have the for loop. This time I'm going to set the value to be equal to 99. I also wait 100 milliseconds. I display the number that we have and also check to make sure that it's equal to 99. If the current value is 99, I display good. Otherwise, I'll display bad. And then we have the check to see if the second thread is complete. So let's run this through and see what happens. Thread 1 ran through, oh, I forgot to make one modification inside this guy here. I want to say that I'm going to run this 10 times, but I also need to call this thread from here, because right now I wasn't calling it. So we already seen that we can call a second thread by using this function call here, begin thread, and I want to specify, please begin the thread called main4. Okay, let's see what happens when we run the program. We see we have some good and some bad. We see we have bad, good, bad, good, bad, good, and so on, all the way down, and then here it flips. It goes good, bad, good, bad, good, bad, and then it flips again and bad, good. So we see that what's happening is one thread will set the value to whatever it desires, 10 or 99, but then by the time that we get to the print statement, the value has changed because we're using the exact same variable in the other thread and we're updating its value here. So we need some sort of protection around this variable I_value so that when one thread has access to it and we set a value to it, then we want to prevent the second thread from changing that value. There are a number of synchronization functions to do this kind of operation. If you go back inside of MSDN, take a look. Have a look through critical sections as well as have a look through mutexes. You can use them, or even semaphores to synchronize your data. What I'm going to show how to use are critical sections because they're one of the easier ones to understand and use. To start off with a critical section, we have to create a member variable for the critical section. I'm going to make it global here so that I have access to it through both threads, but you could also put it directly inside of the structure if you wanted to. It doesn't really matter. So I'm defining it here as G_critical section. Before you use the critical section, you need to make sure you initialize it. So I'm going to do that right down here by calling initialize critical section, and we're passing in the address of that critical section variable. At the very bottom, once you're done working with the critical section, you also need to clean up its memory, and I can do that by calling delete critical section, and again, we're passing in that same address for the critical section that we declared up above. Alright, so now how do we use a critical section to protect our own variables? Take a look at this code here. Right before we go and change the value of a variable that's going to be accessed by both threads, we enter our critical section. So we say enter critical section, and what that does is it says, okay, whoever is going to have access to this critical section, we now basically locked it to tell that a thread has entered into a specific section down below. So everything below enter critical section now has been locked away from all other threads. So we can set the value, we can sleep here for 100 milliseconds, and then we can print the value. After doing that, we want to leave the critical section, and we do that by calling leave critical section. So basically, everything between enter and leave is now locked away from all other threads. We need to do the exact same sort of thing inside the other thread so that right before we set the value, we're going to enter the critical section, like so, and then after we print the value to the screen, we then need to also leave the critical section. So let's run this code. Notice now that all the values for all 10 iterations through both threads, all the values here are considered good because we're not interfering with each critical section. To recap here, a critical section is basically a block of code that you can define using one of these critical section objects. And by saying you're going to enter into a critical section, you basically lock away all other threads. What is happening in the background here is, for example, let's take a look here. This main thread will go here, we'll initialize our critical section, so we assign some memory to this variable, and then we enter into a critical section. As soon as we do that, then when the second thread, this guy here, tries to enter into its own critical section, the program already knows whether this variable is locked or unlocked. If it's locked, then this thread gets held up until leave critical section is called for this critical section variable. As soon as leave critical section is called from the other thread, then this thread has access to go into this section here and execute itself. So you're basically creating a locking mechanism to prevent your variables from getting overwritten by multiple threads at the same time. And I said again, this is only an introduction to how you could use, how you can prevent your variables from getting overwritten. I also recommend you take a look at MSDN, take a look at mutexes, take a look at semaphores if you have more advanced data processing that you want to do between different threads. You will want to protect your data to prevent bugs from showing up in your code, but also protect your data from causing memory leaks and corruption. So I hope this was a good introduction to you for threads and how to synchronize threads with one another. You're not restricted to only declaring one thread. If you want to have your main thread spawn multiple threads, just continually call this function here, specifying each different thread that you want to start up. Just remember that whoever starts up the threads, you shouldn't exit the main thread until all those spawn threads have finished executing. If they're just doing small tasks, then you don't necessarily need this kind of handling here. However, it's always helpful to have this sort of check to make sure that you don't run into some sort of error conditions where your threads end up locking one another and preventing you from exiting. When working with multiple threads, you also have to be careful with deadlocking, which is basically a condition that you can put yourself in if you have both threads waiting for the other threads to change a value, but they're both waiting at the same time. So you basically locked your program from being able to execute further because thread 1 is waiting for thread 2, but thread 2 is waiting for thread 1 and nothing is being processed. So that's considered a deadlock. To prevent yourself from getting into deadlocks, you should use synchronization functions to manage your variables and things like that.